Hi guys, welcome back. There is a biological event your body is capable of that simultaneously activates more brain regions than almost any other human experience, releases five distinct neurochemical compounds in a single cascade, produces measurable pain reduction comparable to some pharmaceutical interventions, drops cortisol levels within minutes, and leaves the brain in a state that sleep researchers describe as one of the most reliable natural pathways to deep rest. It is not exercise, it is not meditation, it is not any supplement, it is the orgasm. And the neuroscience of what happens in your brain during and after one is genuinely remarkable and has remained largely undiscussed in mainstream health content despite a solid and growing body of peer-reviewed research. In the next few minutes, you are going to discover the precise five-chemical neurological cascade that fires during orgasm, why neuroimaging studies show the brain during orgasm resembles a system under both intense activation and partial shutdown simultaneously, the documented pain-reducing effects of oxytocin and endorphins released during climax, and what clinical research says about their magnitude, why cortisol drops measurably afterward, and what that means for stress physiology, and the evidence on how this affects sleep quality and long-term mental health. Let's get into it. To understand the neuroscience here, you need to start with what's happening at the brain level during the buildup and peak of sexual arousal. During sexual arousal, the brain's dopaminergic reward system, the mesolimbic pathway running from the ventral tegmental area to the nucleus accumbens, begins activating in the same way it does during other high-reward experiences. Dopamine, the neurotransmitter associated with motivation, anticipation, and reward, surges through this pathway. But here's what almost nobody outside neuroscience laboratories knows. Something unusual happens to one specific brain region at the moment of peak arousal that makes this experience neurologically unique. Neuroimaging research has documented that the lateral orbitofrontal cortex, the region of the brain most directly responsible for behavioral inhibition, self-monitoring, rational judgment, and executive control, deactivates at orgasm. It doesn't just quiet down, it measurably shuts off. This temporary deactivation of the brain's primary self-regulation center is part of why this experience feels qualitatively different from other pleasurable experiences. The system that normally maintains conscious control, evaluates consequences, and monitors social appropriateness goes offline, which is why the experience tends to eliminate anxiety, rumination, and stress-related cognition in a way that most other pleasurable experiences do not. Simultaneously, at the moment of orgasm, a precise neurochemical cascade fires in rapid sequence. Dopamine surges, signaling peak reward and producing the intense, pleasurable sensation. Norepinephrine elevates, producing heightened arousal, increased heart rate, and the characteristic physical intensity of the experience. Endorphins flood the system. These are the body's endogenous opioid peptides, the same family of molecules that produce the runner's high, and that pharmaceutical pain medication was designed to mimic. Their release during orgasm is substantial and produces genuine analgesic effects. Oxytocin spikes, released by the pituitary gland. Oxytocin is most commonly known as the bonding hormone, but its physiological effects extend far beyond bonding. It has documented anti-inflammatory activity, direct stress-reducing effects on the HPA axis, and research published in Frontiers in Endocrinology has specifically examined its role in reducing fear, stress, and pain perception. And prolactin rises, producing the characteristic post-orgasmic relaxation, reduced arousal drive, and what many describe as a profound calm that follows. 5 neurochemical systems, firing simultaneously within seconds. This is one of the most complex and rapid neurochemical events the brain produces outside of acute stress or danger responses. But here's where most people get this completely wrong. The conversation around this topic in mainstream media almost always stays at the level of pleasure and bonding, the dopamine and oxytocin story. The more clinically significant findings are the pain reduction and stress relief mechanisms, which have a more rigorous evidence base than most people realize. Let's look at the pain reduction evidence specifically. The endorphins released during orgasm are endogenous opioids, meaning they bind to the same opioid receptors in the brain and spinal cord that prescription pain medications target. A systematic review and meta-analysis published in the Canadian Journal of Pain examined randomized controlled trials and observational studies on oxytocin specifically for pain management across 1,504 people. The results found statistically significant pain-reducing effects, particularly for chronic pain conditions. Oxytocin's analgesic properties are now a legitimate area of clinical pharmacology research, with the University of Florida running a clinical trial specifically examining whether oxytocin can reduce opioid requirements in pain management. Neuroimaging research has also documented that orgasm and pain actually activate some of the same cortical regions, and that vaginal stimulation in particular has been shown to measurably reduce pain sensitivity in controlled research settings. The mechanism appears to involve both the endorphin release and specific descending pain inhibition pathways that are activated by the same neural circuits involved in the orgasmic response. This is not trivial. Research has documented that sexual arousal can raise pain thresholds meaningfully, with some studies finding it comparable in magnitude to mild analgesic medication. People who experience pain during sexual activity are often surprised to find the pain diminishes at orgasm rather than worsening, and the neurological reason for this is now understood. Now let's talk about stress, because this is where the clinical implications are perhaps most practically significant for most people. Cortisol, the primary stress hormone secreted by the adrenal glands, drops measurably following orgasm. The mechanism involves multiple pathways. Oxytocin directly suppresses HPA axis activity, the hypothalamic pituitary adrenal system that drives cortisol production. Prolactin, rising steeply after orgasm, also has cortisol moderating effects. And the deactivation of the orbitofrontal cortex during peak arousal temporarily interrupts the rumination and threat monitoring patterns that sustain elevated cortisol in stressed individuals. Research published by Medical News Today in its clinical review noted that while some earlier studies produced mixed results on whether orgasm directly lowers measurable cortisol in controlled conditions, the neurochemical cascade, particularly the oxytocin surge, creates physiological conditions strongly associated with parasympathetic nervous system dominance, which is the body's rest and recovery mode, the opposite of the fight-or-flight state associated with stress. A 2019 study surveying 778 adults specifically examined sleep outcomes associated with orgasm. The findings were consistent. The substantial majority of respondents reported that orgasm reduced the time it took to fall asleep and improved their perception of sleep quality. The mechanism is well supported neurologically. Prolactin, which rises steeply post-orgasm, is closely associated with sedation and the onset of deep sleep. The parasympathetic shift produced by the oxytocin and prolactin surge creates ideal physiological conditions for sleep onset, and there is a longer-term mental health dimension worth understanding. Research suggests that oxytocinergic activity, the sustained activation of oxytocin receptor systems, may support neuroplasticity, the brain's capacity to form new neural connections and reorganize itself. This connects the immediate stress-reducing effects of orgasm to potentially longer-term benefits for emotional resilience and cognitive flexibility. Longitudinal research has found associations between regular sexual activity and better mental health outcomes, better cognitive performance in older adults, and reduced risk of certain neurological conditions. Though it is important to be clear that these associations are complex, influenced by confounding factors like relationship quality and overall physical health, and are not yet at the level of causal proof. What is clearly established at the mechanistic level is the neurochemical cascade, the pain reduction effects through endogenous opioids, the cortisol moderation through oxytocin and HPA axis suppression, and the sleep facilitation through prolactin elevation. But here's what changes everything about how you should understand all of this. This neurochemical event, this precise 5-compound cascade, is not rare, exotic, or dependent on external circumstances. It is a biological capability built into the human nervous system, and the research on its physiological effects positions it not as merely a pleasurable experience, but as a genuine self-regulatory mechanism, one that reduces pain, lowers stress hormones, facilitates sleep, and temporarily interrupts the brain's self-monitoring systems in ways that provide measurable neurological relief. The reason most people don't think of this in clinical or neurological terms is partly cultural and partly because mainstream health content has been reluctant to discuss it seriously. But the peer-reviewed literature has no such reluctance. The neuroimaging studies exist. The pain reduction meta-analyses exist. The oxytocin clinical trials exist. The sleep research exists. Let me bring everything together. During orgasm, the brain simultaneously activates its reward system at peak intensity and deactivates the region responsible for self-monitoring and rational control. 5 neurochemicals fire in rapid cascade: dopamine, norepinephrine, endorphins, oxytocin, and prolactin, each producing distinct and documented physiological effects. The endorphins reduce pain through the same receptor systems targeted by pharmaceutical opioids. The oxytocin suppresses the HPA axis and drops cortisol, shifting the body toward parasympathetic recovery mode. The prolactin surge creates ideal conditions for deep sleep onset, and the orbitofrontal cortex deactivation interrupts the rumination and threat monitoring loops that sustain anxiety. The real question was never what happens to your brain during an orgasm. The real question is, why does modern health culture discuss cold showers, meditation, and supplements extensively, while largely ignoring one of the most well-documented natural neurochemical reset mechanisms the human body possesses? If this gave you a completely new way to understand your own neuroscience, subscribe butts, because next week we go even deeper into the biology of how your brain and body regulate themselves. See you in the next one.